Today's topic is something that has been fundamental to the entire universe, yet it is something which we do not entirely understand yet, at least its physical properties. We talk about energy.
According to Albert Einstein's famous equation, E equals mc squared, energy and matter are two different states of the same thing. The amount of energy saved in matter should be its mass multiplied by the speed of light squared. So, why is it that we still have to think and research intensely to secure our growing future energy supply?
One of the reasons is that today more than 80% of the global energy supply comes from fossil fuels, mainly oil, coal, and gas, as well as nuclear energy. However, renewable energies have seen a significant boost in recent years, and the Biden administration plans to invest up to $2 trillion in renewable energies in just 4 years. Global politics aims to fully decarbonize the power sector by 2035 and upgrade economies to become net zero in carbon emissions in 2050.
But is it possible to become clean? Buckle up and explore with us.
Welcome to the UTX podcast, featuring a utopia created by technology, presented by your Techniax. I am Val.
And I'm Ani, and today we're going to talk about the future of energy. We'll first take a look at our current energy mix and why we need to change it. Then we will look at existing energy sources as well as potential new candidates. We then take a look at the challenges we face to transitioning towards renewable energies before we sign off with our signature utopian day in the life. Let's dive into it.
Let's look at what we have currently, our current energy mix, and why is it that we want to change it? Now, as you know, the main reason for which various stakeholders urge us towards an energy transition is not the scarcity of fossil fuels primarily, but the fact that they are made of carbon, which transforms to carbon dioxide when burned, a greenhouse gas. Research suggests that these greenhouse gases cause global warming, as they prevent solar energy reflected from Earth to go back to space, and thus entrap it, making the Earth warmer.
And we base this on a McKinsey energy research that we'll link in the description if you want to check it out for yourself. And the research suggests that the growth of global energy demand will slow down a bit and will come to about 0.7% growth per year, down from 2%, which it was between 2000 and 2015. The reasons, they say, is that in a slower population and economic growth, higher energy efficiency, digitization, and a decline in the Western world and a general shift from producing goods to services are the reason for this slow or this drop in the demand or the growth of global energy demand.
Now, with the current energy mix, there are reasons to be optimistic about our energy future, and there are also reasons to be pessimistic about it. One of the reasons to be optimistic is that by 2035, McKinsey estimates that it will take more than a third less energy to power a fossil fueled car than we need right now. Another reason to be optimistic is that the so-called energy intensity, which reflects how much energy is needed to produce 1 unit of GDP, goes down by half from 2013 to 2050. However, the global demand for electricity is expected to grow twice as fast as the demand for transportation, growing to a 25% share of global energy demand. And this is attributed to the growing human population, which needs more energy.
Now, according to McKinsey, 77% of the energy capacity added to the mix, that is, of the new energy capacity, will be derived from wind and solar energy. And these are expected to grow 4 to 5 times faster than any other energy source, meaning that they will account for 1/3 of power generation by 2050, which, to be honest, is still a surprisingly small share. And 13% of capacity growth would come from natural gas, 10% would come from any other energy source, which would also include nuclear and hydrogen sources.
The reason that fossil fuels will dominate probably all the way through 2050 is because they have just shown to perform well in terms of energy intensity and also reliability, but also because large investments, large fixed commitments have already been put into those energy technologies over the years.
Now, they do see a decline in their share, but for oil, coal, and gas, it would mean dropping from 82%, where it is now, down to 74%, which is still very high. And McKinsey also predicts that the energy related greenhouse gas emissions will rise by 14% in the next 20 years due to the growing world population.
Yes, the study has been written a few years ago, and projections might look a little more favorably towards the energy transition right now, based on the political pressure and the public pressure that is applied to it. But nevertheless, this whole outlook looks a bit too non-utopian, even for 2016 when it was written. Especially as you know, we like to see new technologies, and this is also probably why you watch us. We like them to thrive and solve our problems. So that's why we want to explore all major new energy sources today to see if we can do something about that forecast collectively.
There's a very dystopian book written by Professor Stephen Emmett back in 2012 called 10 Billion, where he predicts how the world will grow to 10 billion and what it will mean. But we believe that with technology, we can bridge this and hopefully find better sources of energy. So let's look into what energy sources exist and what potential candidates we can pick up on. So first, we have to distinguish between primary and secondary energy sources. And primary energy sources are ones that are ready to use, whereas secondary energy sources are ones that need to be converted first before they can become of use. Primary sources include wind, solar, coal, oil, and gas, as well as uranium. And secondary sources are electricity, hydrogen, and other synthetic fuels. And obviously, you'd also need to distinguish between renewable energies. And renewable energies are those that are abundant or part of an energy pool that would recover within a human lifetime. Examples of these would be solar or wind or any other classic non-renewable energy. Or any other renewable energy, excuse me. And the opposite of renewable energies are non-renewable energies such as oil, coal, natural gas, and uranium for nuclear fusion, because these energy sources take millions and millions of years to form, but we are using through them at a pace at which these energy sources cannot be replenished.
When popular culture talks about renewable energies today, they mainly talk about wind, solar, biofuels, geothermal, as well as hydro and oceanic. How is the share between those technologies? As of 2017, the global energy supply was derived 20%, so one-fifth from renewable sources. Biomass contributes almost half of it, so 10% of the global energy supply was biomass, and roughly 20% of those 20%, so that is 4% each, was derived from hydro and geothermal, and the rest comes from wind and solar, the rest of the renewable energy share.
Now, renewable energies, apart from being renewable, also have the advantage of producing less carbon dioxide. And they can also be deployed in remote or rural areas, but it might not always be suitable. For instance, wind energy is very dependent on areas that have a lot of wind. But renewable energies can also help countries to reduce dependence from foreign energy sources. And they can also save maintenance and operating costs. So there are many benefits of using renewable energies, obviously.
And one of the prerequisites of using renewable energies many times is that the geographical properties of a specific location need to favor those energies. And in case of Iceland and Norway, but not just because of that, but also because of their political will and their way of moving things forward, these two countries already generate close to, or even fully, close to 100% of their energy mix from renewables. Globally, by 2017, global investments to renewables stood at 280 billion US dollars, and China accounted for 45% of that. US and Europe combined only contributed around 30%. So think about this when you hear about the EU's role as a pioneer in renewables, when in fact China is also very active in the space and contributes a lot. The renewable energies industry, is estimated to employ around 10 million people, more than 10 million people globally.
That's more than the entire Swiss population.
Yeah.
And now we come to one of the forms of renewable energies, which is hydropower. And they're the largest contributor of energy of all renewable energies. And hydropower is the use of energy of water flow through dams, especially in lakes, rivers, and even in oceans. And the world's capacity for hydropower in 2019 was 1,190 gigawatts, which is almost as much as solar and wind combined. And hydropower is very popular. It's produced in 150 countries, with the Asia Pacific region accounting for almost a third of global supply. One big famous one would be the Three Gorges Dam in China, which is such a large dam that it has even slowed down the Earth's spin. So hydropower is very popular in the Asia Pacific region, and it tops the energy mix of most of the top 50 energy renewable, or it tops the energy mix of most of the top 50 renewable energy countries. So it's definitely a very powerful and widespread form of renewable energy.
Absolutely, and it can also be applied to oceans. So a futurist approach to hydropower is using oceanic energy, which comes from the kinetic energy of waves or tidal power. So-called coastal wave farms have been deployed in the US, Australia, UK, and Portugal already. Wave farms are resource intensive and can mostly not rely on offshore grids for energy transmission. No infrastructure is pre-built there. Its impact on submarine ecosystems, flora, and fauna are not fully understood and are being studied. Tidal energy systems rely on sites with high tidal ranges and flow velocities. However, tides are more predictable than the wind or the sun, at least. Costs for tidal energy were historically high. Yet developments in design and turbine technology accelerate its progress by bringing those costs down. Electricity generation increases by about 10 to 50% each year.
So this is important to notice because the other forms of hydropower, so that would be dams that are constructed along rivers, usually have very expensive side effects, such as having to resettle entire villages, and they can also decrease water quality, make it harder for certain animals to naturally move along the river, such as for fish. So while it is the largest contributor to renewable energy, it's not without its negatives. But now we move on to wind energy, and wind energy uses air power to operate wind turbines. And obviously, energy generation depends on the speed of the wind, and wind turbines are strategically placed in areas with constant and stronger winds, such as offshore or high altitude sites. By 2015, wind energy was responsible to meet 4% of global electricity demand, and it was supplying more than 40% of Denmark's electricity, as well as almost 20% in Spain and Portugal.
So wind energy is also really relevant. And once again, we have a more futurist approach to wind energy as well. And in this case, it is what the state of Alaska and the MIT startup Alteros are deploying, which is the world's first airborne wind farm. It will float around 1,000 feet, so around 300 meters above ground, because the wind is stronger there. And the project costs around $1.3 million. So you could consider this an early prototype. And it's planned to feed over or several dozen of homes in the area.
That is very interesting. Yeah, wind. In fact, we see many wind turbines placed in neighboring countries of Switzerland, and they are definitely a popular option as well. And now we move on to the third biggest renewable energy contributor. Slightly behind wind, however, with the highest potential is solar energy. In 2015, Italy had the highest share of solar energy in their mix, with solar contributing 7.7% of all electricity in Italy. Solar energy usually relies on photovoltaics, which are semiconducting materials in that they convert sunlight into electrical energy.
And as you know, it also relies on area, on flat surfaces or surface in general where you can install those photovoltaics. And one innovative approach to increase those areas would be to use windows. And solar windows are essentially transparent windows which are able to transform sunlight into electrical current. They are built using light harvesting perovskite material instead of silicon, which most photovoltaic panels are built from. 2 square meters of solar windows are enough to create the same amount of energy than a standard solar panel, which means that perovskite based panels are not just more affordable alternative, but they're also more efficient than the silicon based photovoltaics in turning sunlight into energy.
Now, solar energy doesn't necessarily have to be on in windows or on rooftops. It could also be in outer space. And this is because solar radiation is much higher outside the Earth's atmosphere. And here it works by placing photovoltaic solar panels inside Earth's orbit, which then wirelessly transmit energy to a receiver antenna on the ground using either microwaves or lasers. Um, all the necessary technology for such a utopian undertaking are have already been proven to work, with the space launch infrastructure to bring a multi-kilometer sized solar panel to space still being too expensive to make it economically viable. But hopefully this changes in the next decades, and it even might. So uh, you can maybe see this in our lifetime. But if you want to learn more about space and space colonization, as well as uh, or if you want to learn more about space in general, we made an episode 4 of our podcast was on space colonization and humanity's place beyond our planet.
And yet, maybe we don't even have to go to space to receive our energy supply, especially because space has already given us a lot of energy, or essentially all of energy. And now we have two examples of energy sources which are based on the Earth. And the first one is bioenergy. It contributes around 124 gigawatts of energy per year. It works based on biomass, so biological material derived usually from plants. The largest source of biomass today are still woods. Industrial applications feature plants such as corn, sugarcane, willow, hemp, switchgrass, or bamboo, as well as tree species such as eucalyptus or palm. Biomass itself can be used for combustion or serve as the basis for biofuels, with ethanol and biodiesel being the most prominent ones.
And you mentioned ethanol. Ethanol is an alcohol, and it's usually made by fermenting corn or sugar cane. And it essentially converts the sugars into energy. And it is often used as a fuel or a fuel additive, especially in the US and Brazil.
As opposed to those two countries, in Europe, the biofuel used usually is biodiesel. Biodiesel is produced from fatty sources such as soybean oil, vegetable oil, or animal fat, which are made to react with an alcohol to form the fuel. Usually, that biodiesel is added to or is used as an additive to other fuel to reduce emissions such as carbon monoxide.
So we move on to another renewable energy, which is geothermal energy. And this one is significantly smaller than the previously mentioned renewable energies, accounting for only 14 gigawatts per year. So that's like 1/9 of bioenergy, which in itself is the fourth largest. So geothermal energy, much like the name suggests, relies on heat stored in and released by the earth. The Earth's geothermal energy originates from its core, from the radioactive decay of minerals, and from solar energy.
And the heat that is stored in the earth can emerge to the surface in many different forms. Lava or magma, depending on how close it is to Earth's surface, is underground molten rock, which convects upwards as it is lighter than solid rock. Other types include, and here I quote from National Geographic, hot water, usually released through geysers, hot springs, steam vents, underwater hydrothermal vents, and mud pots.
You
One,
mentioned hot water from geysers. Um, in Iceland, which is an island that is placed over the border of two continental plates,
and is fully
has
renewable as well.
exactly is runs on. They have many geyser pools where warm water comes out of the earth, where people can kind of bathe in. So that's what that means, and it's very interesting. I just felt reminded when you spoke about geysers.
Absolutely. And a pretty close neighbor of Iceland, Finland, is also a pioneer in geothermal energy. Finland has just drilled the deepest geothermal well, which shall allow it to become climate neutral by 2035, 15 years earlier than aimed by the EU's Green Deal. They say that for 10 gigawatts of energy produced, they only need 1 gigawatt of energy to run the pump, making this a 90% efficient technology. Challenges, however, remain regarding potential disruptions to the Earth's underground, which could cause earthquakes.
Now we have to mention another one, which another source, which are anti-solar panels, and they derive their name from the fact that they convert solar energy coming from the opposite direction. That's right. You might wonder, what are they talking about? The opposite direction refers to the energy that the Earth radiates, and thus it's technically a geothermal technology. Now, a thermoelectric generator uses the heat which is stored and then released overnight to produce electricity. And these anti-solar panels work based on the so-called Seebeck effect. And the Seebeck effect explains or basically says that two conducting or semi-conducting materials with different temperatures exchange electrical currents between each other based on their voltage difference, of course. And in anti-solar panels, this effect is achieved by unevenly releasing stored heat through radiated cooling. Now, the University of California and Stanford University, both, of course, strategically well placed institutions for this, have experimented with such panels. However, exciting and exotic as it sounds, their efficiency is still uh, in the magnitude of 1,000th below that of solar panels. So, unfortunately, anti-solar panels are just, or at least still only in the research phase and not really a viable renewable energy.
So maybe we have to still consider also other options, and one of them features the most abundant element in the universe, which is hydrogen. However, on Earth, at least in its purest form, hydrogen is kind of hard to extract. It is not as easy to access because it usually is part of chemical compounds like water molecules. By extracting the hydrogen from molecules, it can be made available in electrochemical fuel cells as combustion fuel ready to interact with oxygen, not emitting any carbonic material when being burnt. However, the cost for producing hydrogen is still comparatively much higher than using fossil fuels. So we say around $3 to $6 per kilogram of hydrogen versus $1 to $1.80 per kilogram of fossil fuels. Additionally to the fact that in most cases, those very fossil fuels are needed to produce hydrogen. even if recent advancements in renewable energies promote those to be also used for hydrogen production. Thus, hydrogen is rather considered an energy carrier, like for electricity, than an energy source itself. However, much of the infrastructure built to carry natural gas can also be used to carry hydrogen. Many jurisdictions are working on hydrogen strategies, promoting the technology with partly gigantic projects featuring the EU, Australia, Germany, Portugal, the Netherlands, and Japan.
Now, uh, another, and this is really an innovative source, is that we humans don't just consume a lot of energy, we also produce a lot of it, especially during the day. So there have been some approaches to utilize human produced energy, including converting footsteps and workouts into energy, or maybe taking a small share of the energy produced by body heat or blood flow, or even using urine and feces to create biomass. Back in 2012 already, the Center for Nanotechnology and Molecular Materials at Wake Forest University, North Carolina, developed a small thermoelectric device which created electricity based on the electric charge associated with temperature differences between the air and the human body. The small piece, based on carbon nanotubes and plastic fibers, can be attached to a phone for charging. So you could charge the phone just using your body heat. And even there was a project at the Google Science Fair, um, where someone had invented a torchlight that would power itself just using the body heat. So that's very useful for emergency situations. So utilizing our own excess energy is definitely a interesting and innovative approach.
Absolutely, because no energy is ever lost, it's only changing its form. And one of those forms, and the next and last example, is not technically a renewable energy example, but it's a good example for recycling energy, is using nuclear waste. And nuclear power, as you know, is still one of the major contributors to the energy mix in many countries. As a result of nuclear fusion, a process in which two or more atomic nuclei of heavy elements, such as uranium or plutonium, are combined with each other to release energy, nuclear waste in form of radioactive material, so-called fission products, is created. The radioactive material can be reused to again serve as fuel for nuclear reactions. Also, the remaining waste decays to become harmless within a few hundred years rather than a million years, as is the case with unrecycled radioactive waste. The World Nuclear Association, however, states that only around 30% of that nuclear waste currently is being reprocessed or recycled. The main reason for this lies in the costliness caused by the complexity of the recycling process, which needs to be conducted underground and includes complex chemical processes to arrive at a reusable end product. Today, 70% of nuclear waste is stored either in reactor pools or fuel storage facilities. The energy potential of nuclear waste, however, is significant and could increasingly become a viable energy source in the future.
So we have heard a lot of not just existing but also potential and very innovative methods to find new energy sources. But of course, just because we find energy sources that are renewable doesn't mean that we have solved the problem of our energy use uh, and climate change. There's also the aspect of integrating it into a system that has already created large infrastructure investments into old energies. So there are quite a few challenges in the transition towards becoming clean or towards renewable energies in general. So let's take a look. One of the challenges are that biomass and biofuels that we saw were produced from corn, hemp, and other biomaterials. They directly compete with food supply, as these crops producing for these could also be used for alimentation. And they also consume large amounts of water. And given that not everyone has access to enough food and water, using biomass and biofuels seems unethical.
Also, other renewable energy sources occupy large areas of land or marine ecosystems, and they are posing a threat to biodiversity in many cases. In relevant locations, such as installations in coastal zones to utilize tidal energy, but also other hydro as well as wind and solar power installations, they pose a threat towards conservation areas, biological ecosystems, and marine life. They need large areas of land many times, which are much larger than the fossil fuel power plant alternatives, comprising significant areas.
Now, renewable energy devices and even many batteries that are used to transport the energy won from renewable sources rely on, ironically, non renewable resources to be manufactured. And these include mined metals, rare earth metals, which can occur in relation to radioactive materials. So, even renewable energies, because of their association or because of the association of the process of winning them, can still be not entirely clean.
And this is why, with emerging technologies, we usually focus also on their scalability. Because you always need to think, if this technology becomes big, if it becomes a big supplier of anything to us, for instance, energy, you need to think, what do we need to produce it, and what happens when that supply chain is being expanded. And in the case for renewable energy, obviously these challenges also materialize in bigger scale when the growth of renewables is supposed to happen. Strategic planning, avoiding sensitive locations, and continuing research on more eco-friendly materials as an input for renewable energies are important, and renewable energy infrastructure as well, of course.
So now we turn to a survey by Deloitte. I know, two consulting companies in one episode, crazy. And they surveyed the most intricate obstacles towards energy transition. So many of these companies named access to and availability of renewable resources, the currently still very high cost of electric vehicles, difficulties in attracting talent with the right skill set, as well as the intermittent nature of solar and wind energy, which are not always available, and their availability depends on local geological and climate circumstances, making them not as reliable as fossil fuels.
Additionally, what we need to mention is that there's also issues with power quality, namely voltage and frequency fluctuations. The deployment of large wind or solar power plants oftentimes causes harmonic resonance, meaning that instruments emit electrical waves, which can cause damage to other instruments, including reducing their lifetime or impeding the voltage and thus the quality of electricity produced.
So, uh, despite all this, we still have the cost for energy generation through renewables that is continuing to fall. After an initial expensive installation and investments into storage systems, which in many jurisdictions is heavily subsidized, solar projects can produce energy for half the cost than fossil fuels and will become even cheaper in the future as adoption continues to grow. So it really depends on this or this continued subsidization of renewable energies.
So subsidization is one important factor, and the organizations that took part in the Deloitte survey also mentioned other factors which could ease the renewable energy transition. In order of importance, what they said is policy or regulatory changes, technological advances, more renewable resource availability, availability of additional financing sources, so subsidies or financing structures, more third-party energy service providers that can provide not just equipment but also expertise, simpler contracts and markets when it comes to renewable energy and when it comes to carbon dioxide offsetting, as well as higher availability of workforce with the required skills.
Now, when it comes to challenges regarding electrifying their own industrial processes, almost half of the respondents in the survey, which by the way is linked in the description, almost half of them mentioned the very high cost of replacement as a big factor. And this was followed by unclear benefits, lack of funding and financial initiatives, as well as a lack of suppliers and available alternatives. And these were also mentioned by more than 20% of respondents. So there's still a long way to go and many challenges, not just on the actual energy side, but also in our transition towards them.
So now that we've peeked into the future of and with renewable and clean energy, and we've seen what are the potential roadblocks to reaching there, now it's time again for the fun part, which is the utopian day in the life of the Techniax, in this case powered by clean energy sources. During breakfast, I am in particularly good mood in this utopia, or this utopian day, because I have the satisfying thought that my house, as well as my self-driving car, they earn me money by feeding self-produced but unused solar energy back into the smart grid. And this is one of the features of a smart grid, that you can actually earn money with it. But you could also argue that in the future, with all those technologies coming into play, maybe there is such an abundance of energy that it will have a very low price, which I mean, you cannot earn as much with it anymore, but then the benefits are also quite obvious.
Just to mention, our utopian energy mix now consists mainly of solar and wind power, aided by a bit of geothermal energy and hydropower, making our energy system fully renewable and carbon neutral. This includes floating wind farms, oceanic energy in strategically well placed deep ocean locations, but it also focuses on conserving surrounding ecosystem integrity and biodiversity. Nuclear waste is now fully being recycled and adds significantly to the energy mix, while the last nuclear reactors are being put to rest and are being transformed into museums where people can come and see these old ways of energy production. Anti solar panels, thank God, have revolutionized the geothermal energy field and are utilizing the Earth's capacity to store and release heat, especially in very hot, sun spoiled locations.
Amazing. And now it's time to go to work. And I work for my startup Neurofuel. It develops brain computer interfaces supporting technology for brain computer interfaces, which enables these devices to run without external power, only by using the electrical current that is produced in our brains by our thoughts, by the neural transmission inside the brain. And Neurofuel even plans to, in the future, create an excess of energy based on brain activity, and especially um, emotional states that create heat. So your boss could really become part of the energy transition in the future.
So during the coffee break, I am charging my phone. Of course, I don't need a charger. My phone charges while I'm walking. I can charge my phone entirely with kinetic energy and based on thermoelectric material, which generates electrical current based on temperature differences between my body and the material. And I was also coming across an article about a new a new energy source, which would be other stars. So to harness powers from entire stars, because as we know, these stars output more energy per square meter per second than all the reactors in the world combined. So it looks like our energy supply is going to go through the roof.
So in the evening, I watch a fully wireless 3D hologram of the news because energy transmission over the air has now majorly advanced. What has also advanced is space-based solar power systems. In a collaboration of international space agencies and private space companies, such a space-based solar power system has been installed in Earth's orbit. It features a large satellite, several square kilometers of solar panels, and microwave transition to receiver antennas on Earth. The international team is constantly extending the capacity of the system, which now is a major contributor towards our global energy mix.
So it looks like we are finally inching our way up to a type 1 civilization on the Kardashev scale. But if you've heard of this scale, probably from the Kurzgesagt video, we know that we still have a long way to go, but we have a very utopian day, and we are no longer polluting our earth in search for energy. So this is not just a utopian day in the life, it's a utopian year or a utopian humanity.
So if you liked this episode on the future of energy, you should stay tuned for our upcoming episode where energy also plays a major role, which is the future of mobility. And in the meantime, you should make sure to subscribe to us on YouTube, as well as if you're listening to us on any of the major podcast platforms, including Spotify, Apple Podcasts, Google Podcasts, or Stitcher, make sure to follow us there or to read our blog on Medium.
As
Also,
always, go ahead.
we have bite-sized videos of our episodes featuring one of the most important moments or the most knowledgeable moments of those episodes in bite-sized clips. So make sure to check that out on YouTube as well.
And subscribe, because we have a lot of things coming beyond just the utopian future. So we'll have some big announcements some weeks in advance, or in some weeks' time. But until then, stay patient. And as always, stay utopian.
Your Techniax.